Hi there, welcome to this video on upper and lower bounds, looking at 3 exam style questions. So question 1, the length of the line is 63 centimetres, correct to the nearest centimetre. Write down the least possible length of the line. So it's worth considering a number line. Now on that number line, if we're rounding to the nearest centimetre, then let's put some numbers on here: 60, 61, 62, 63, 64, 65. So these are the only possible numbers that we're going to end up with after we've rounded to the nearest centimetre. So if we consider that we've rounded to this value here, then that basically means that the original value was somewhere between this value and this value. Now for the sake of upper and lower bounds, we don't worry about the fact that if it was 63.5 we'd round it up to 64. We just use that as the biggest possible value this could have been, and the smallest it could have been is 62.5, so it's halfway between these two values. So what we're saying is that the number before we rounded it has to be between these two values, and as I said before, we do include both of these values even though we conventionally round this one up to 64, and we call this the lower bound and this is the upper bound. So for this one, the least possible length of the line is 62.5, because anything below that and we'd round it down to 62 or lower. The greatest possible length of the line is the upper bound, which is this 63.5. Question 2. So a field is in the shape of a rectangle. The length of the field is 340 metres to the nearest metre. The width of the field is 117 to the nearest metre. Calculate the upper bound for the perimeter of the field. So let's consider what values we could have started with. So if this is the lengths have been rounded to the nearest metre. So let's put some values relatively near to that. So let's go for 339, 340, 341, 342, and so on. So it's been rounded to 340. So the lower bound is this value here, which is 339.5. And the upper bound is this value here, which is 340.5. So this is our upper bound and this is our lower bound. Now for the width of the field, let's do another number line. That's also been rounded to nearest metre and it's been rounded to 117, so let's just put 117 there. Got 116 here, 118 here. So that means that these values here are the lower bound and the upper bound. So this one's 116.5 and this one's 117.5. So a good idea is to do a little table, and I've got one done here already, and what we're doing is we've got the length and we've got the width. So let's just write down all the values that we've just talked about. So for the length, which is the first thing, the lower bound was this number here, 339.5, and the upper bound is 340.5. The width, the lower bound, is 116.5, and the upper bound is 117.5. So what we've got to do is we've got to find the upper bound for the perimeter of the field. Now if you draw a quick sketch, we've got the length and the width, so we're going to add the length twice and the width twice. So we want the upper bound, so it's the biggest possible value that we could have. Now if we're just adding them, if we take the upper bound for the length and the width, that's going to give us the biggest possible value for both of them. So all I'm going to do is 340.5 times 2 and add on 117.5 times 2, because these are the biggest possible values the length and width could be, so we're going to use those to get the biggest possible value the perimeter could be. So if I work those out, we get 681 and we get 235, and if I add those together I get 916 meters. So the perimeter, the upper bound for the perimeter, is 916. Okay, so final question. The voltage V of an electronic circuit is given by the formula V equals I times R, where I is the current in amps and R is the resistance in ohms. Given that V equals 218 correct to 3 significant figures and R equals 12.6 correct to 3 significant figures, calculate the lower bound of I. So first of all, we need to start with our upper and lower bound. So we are going to need to know the upper and lower bound for v to start with. It's been rounded to three significant figures. That means that it's been rounded to the nearest whole number, because the third column is units, so it's been rounded to the nearest whole number. So again, if you just draw a diagram, if you're still not sure, just put on whole numbers either side 218, and so the lower bound is halfway between these two. So for v, the lower bound is 217.5, and the upper bound for this one is 218.5. now for r, this one has also been rounded to three significant figures, but this time that means it's been rounded to one decimal place. So put 12.6 on your number line, put one decimal place either side of that, 12.5 and 12.7, and so that means this is our lower bound, which is 12.55, and this is the upper bound, which is 12.65. So we've got the information that we need. So what I now need to do is think about which ones I'm actually going to use. Well, we actually want to work out I. So if I rearrange this and divide both sides by r, then v divided by r is equal to I. So the lower bound is the smallest value we can make out of these numbers here. And that's going to be made by making v as small as possible, but because we're dividing by r, we want to make that as large as possible. So I'm going to use the smallest value for r, so v, sorry, but the biggest value for r. So I'm going to do, so the lower bound for I is going to be 217.5, and I'm going to divide it by 12.65, and that gives me 17.19, and that's it. Hope that's helped.